The sun, as our main source of energy on planet Earth, creates climate and weather conditions that will or should influence the way a building is positioned on a site, the size and locations of windows and skylights, the lighting design, and the amount of heating and cooling needed. The sun triggers photosynthesis in plants, which in turn creates life on Earth. But the sun does not always provide us with good things. It also contributes to the deterioration of paints, roofing, wood, and other building materials. Fabric dyes may fade, and plastics decompose when exposed to direct sunlight. Interior designers must plan for this when space planning and selecting materials. Many things affect how sunlight reaches your building site: the distance from the equator, the altitude, the proximity to water, and the presence of shade trees and other large structures around your building. Building orientation should take into consideration the sun's angles. They determine how the ground becomes struck by the sun. In northern latitudes, the angle of the sun is more perpendicular to the Earth's surface and strikes at a lower angle, spreading the waves across a broader surface. In the southern latitudes, the sun's angles are more directly above the Earth most of the year, striking the Earth at larger angles, concentrating the sun's heat over a smaller surface. Local temperature will typically be coolest just before sunrise and warmest in the afternoon. Thermal lag is the Earth releasing stored solar heat. Your site may have a microclimate or different features than those nearby. The proximity to large bodies of water, large plants or structures for shading, wind patterns created by tall structures, heat released from nearby machines, etc. In general, the most efficient way to orient a building is with a north-south exposure, minimizing the exposure on the east and west sides. In cold climates, structures focus on heat retention, protection from rain and snow, and winter winds. Northern structures should encourage passive solar heating, or using non-mechanical methods to keep the building warm. This can be done by minimizing the amount of glazing to help reduce exposure to cold temperatures, and by orienting the building to the south to take advantage of the winter sun. Also, adding dark colors to the south-facing surface help to retain solar heat. In temperate climates, buildings will typically require heating in the winter and cooling in the summer. South-facing walls should be maximized, with shade covering the east and west exposures. Building orientation and landscape help create shade, while window locations aid in ventilation. Deciduous trees grow leaves that shade the building in the summer, but lose leaves in the winter, providing direct access to the desirable winter sun. In hot, arid climates like Arizona, buildings should work to shield themselves from the harsh summer heat, but take advantage of warm winter sun. Dry climates should also work to take advantage of the wind and rain for cooling and adding humidity. Thick building walls made of masonry slow solar heat gain, and when possible, should be lightly colored to reflect sunlight. Shade should be provided over the roof and on the east and west sides. Interiors can open up to the north with large patio overhangs, but all windows and patios should be shaded from the sun. Southern exposure can provide wanted warmth in the winter, but should be protected in the summer. Plants and water features help cool and add humidity to the air. Buildings in humid climates should be shaded from the sun and take advantage of breezes for cooling. East and west exposures are minimized, and windows are designed so they can remain open as much as possible. Floors are often raised above the ground with a crawl space underneath to encourage air circulation, and windows are used on opposite sides of the building to encourage cross circulation. It is best to consider the interior space planning while the building location and orientation is being determined. Spaces that do not need direct access to natural light, such as bathrooms, mechanical rooms, stairs, storage rooms, and utility spaces, can be located on the south or west walls to provide a buffer between the interior space and the outside environment. Spaces that need a lot of cooling, such as a kitchen, can be located on a northern wall. Garages can be placed on the western side to protect the building from the summer sun. Multi-story buildings are often designed in layers. The top layer, or sky layer, is the most susceptible to the outside elements, but may not be as affected by noise. The upper layers are a good location for private spaces. The near surface layer is more accessible to people and activities, but can incorporate semi-private spaces. The surface layer has the most public contact, but is also closest to many of the sources of noise and is where the most active spaces should be located. The subsurface layer will be the quietest and provide the most thermal protection, but could be susceptible to water and does not have the natural light, fresh air, or outdoor views. Sustainable buildings are designed to be sensitive to the surrounding climate. The climate of a site is determined by the sun's angle and path, the air temperature, humidity, precipitation, air motion, air quality, characteristics of the ground surface, and topography of the site. The building location should be carefully considered. The reuse of land can provide social and economic benefits to the community, but also prevents urban sprawl and protects native flora and fauna. A greenfield site is one that has not yet been built upon. Building construction might require the removal of soil, rocks, and other existing materials, which could negatively affect the natural habitats of local plants and animals. Elevating buildings on pilotis or pillars and restoring the earth to the roof can help mitigate these negative effects. Brownfields are sites that have been contaminated by human use. Cleaning and reusing a brownfield can have a huge environmental and economic benefit. Water located near the site can also help improve building health. Water arrives at the building site in precipitation, existing groundwater, potable or drinking water, or wastewater. Architects, landscape architects, and interior designers can incorporate methods to collect rainwater, reduce water use, and recycle water for use in landscaping. Plans can benefit a building site in several ways, and if incorporated correctly, can require very little maintenance. Plans provide privacy and enhance the aesthetics of a building, visually connecting it to its surroundings. Winds are usually weakest in the morning and strongest in the afternoon. Large plants such as trees and shrubbery can provide wind and sun protection, but may also block beneficial summer breezes. Water and plant life can increase humidity and lower the site temperature. Larger bodies of water will moderate the air temperatures and usually provide warmth in the winter and cooling in the summer. Noise is another consideration. If a structure is located in the city, then noise may be an issue, so interior space should be designed to deflect noise from important areas. Plants will slightly reduce the sound level, but they also provide a visual softness, and when the wind blows through their leaves, can help mask any unwanted noise. Water features with fountains also provide masking sounds. Plants and water features can also reduce solar heat gain to the building envelope. While it requires little precious water to maintain, a rocky landscaping in a hot climate will heat the nearby structure, whereas grass or plant life will help cool it by absorbing solar radiation and cooling the air via evaporation. In addition to wind protection, shade, and noise reduction, plants near buildings provide privacy and improve air quality. If you are choosing plants for your project's landscape, consider their shape, density, mature size or height, and the speed in which they grow. Also, consider how much direct sunlight each plant will receive throughout the year. Many non-native plants can burn in the Arizona summer sun. Native plant species have the most chance to survive and require the least amount of maintenance. The building interior responds to the surrounding site conditions by either welcoming them in or closing them off through the use of outdoor spaces, wall surfaces, fenestration, and space planning. Fresh air and sunlight from the outside help to improve the health of a building's inhabitants, but loud noises or harsh direct sunlight can have a negative effect. Like our skin, the building is the interface between our bodies and the surrounding environment. The more this surface cooperates and responds with the surrounding climate and site conditions, the more sustainable the structure becomes, and the more aware the occupant becomes of their environment.